period of time, like about 1 month only. So okay, not too demanding, I guess. Yeah, and next week is the round 1 already. So yeah.
So it's gonna have some sort of like, I guess, on site.
Yeah. But I'm only joining for fun lah. Not really aiming for like any goal.
I mean, I hope it's a good experience.
Yeah.
Sounds well. Sounds like something that you can experience now, I guess.
Yeah. PW, I finished my I&R quite early, so yeah, I'm technically done with it already.
Like, so it's done for you lah.
Yeah.
Right. So I guess we can say that you finish your PW and you also finish your mother tongue.
Oh yes.
Okay, right. So you officially have only 5 subjects.
Yeah.
I might still sound a bit slow or softer today. That's because the COVID recovery does seem to take a long time. Right.
So,
so
I see.
I'm
Okay.
not sure. It seems to be that long. Like there's no sickness, but then the fatigue remains or something. Yeah. So it doesn't seem good for people who have to take papers lah. I think that's a very that just, and there'll be people who experience that. So yeah, right. Yeah, but yeah. So yeah. All right. I did say I want to say something about the Maclaurin and the
today was the A-level math paper 1, right?
paper 1, yeah.
Oh, I see.
P, and then yesterday GP, then math paper 1, then it will be chemistry Thursday, paper 2, and then math paper 2 on Friday. I'm telling you this because maybe your schedule will be similar next year. So the first does start with the bang. It does.
Yeah.
It almost felt like you're gonna have more packed schedule than the O level, but you will also have much more time to prepare. Yeah.
Okay.
Right. So that was my first time. Actually, my first time taking O level and A level. So I can confirm that this sounds obvious, but if you are not physically fit, it is extremely difficult to perform in a way that you would want. That is how challenge? No, that's how the paper is mentally demanding, but you should know all that already, right?
I guess, yeah.
Right. Your senior experienced COVID and finish it kind of 4 days earlier than me, Yankin talking about. And I think he felt the effect very much during the preparation. That means the preparation is not ideal, right? Then it takes that 2 weeks, and then he should feel better than me today. And so, but that makes it a good experience. I can say with certainty that maybe there are certain things that we need to do to even make sure that we sleep the day before. I'm very surprised that I cannot sleep yesterday. Surprised. And so I'm in a borderline of tired and not tired enough. that doesn't help at all today. It really does not, really, right? And I wanted to do more and I cannot do more. That's just what happens in the 3 hours. So I want to do faster and I cannot do faster. I want to confirm more, I cannot confirm. If the question was harder than just now, then you will have more impact. Obviously, that will impact everybody the same, right? So different from personal fatigue, right? But yeah, it's so maybe next year we'll do something according to this experience. Sure. Anyway, so that's not what I want to talk about Maclaurin. And what was the other thing I want to talk about? Man, my thinking is very blurry. What was it? Maclaurin and vector, was it or something? What
integration.
Oh, integration. Okay. So AMAT integration was like a big part, even though if you present it properly, it's a slightly smaller percent than differentiation. So differentiation was actually bigger in percentage than integration. But integration felt significant, right? Maybe surprisingly, it is no longer like that in A level. Differentiation plays a big part. The only integration that will play a big part is the last integration you learned, called DE, differential equation. Somehow
I heard about that. The last question, right?
Last thing, which makes a lot of things like that. And they consistently like that, and they give big marks to that. And partially because I think it's a very applicable integration. I think that is almost applicable just like that. If you ever go to a field where you need to do those kind of things, right?
Yeah.
That's one. And then the by parts and the substitution are what, 3 or 4 marks, something like that. That's it, for each if they both appear, right? If they both appear, that's just smaller than the DE one, right? So, and other forms of the basic one, let's say you want to integrate something become tangent inverse. I guess there's that, but other than that, the integration is a very small part of everything, right? Like that's the feeling. So I'm not saying that you shouldn't spend a lot of time in integration. That's what I'm saying. I'm saying that the O-level integration comes back in full force. Like the simple using the partial fraction, that stays a big part. Like integrating an area, that stays a big part. You want to spend more time on the DE stuff and the area under the graph and the volume of revolution compared to all the integration that you have learned. They are just foundation, I guess.
Okay.
So that's that. So then for the Maclaurin one, remind me, have you studied Maclaurin?
Yes, I have.
So how did wait, you don't ask much question, right? You don't, right? When you finally learned it, right?
I thought it was okay, I think. Yeah, I think it was quite
right. I'm going to summarize Maclaurin like this. Let's see whether it currently makes sense to you. Right? I tell you very roughly that Maclaurin expansion and binomial expansion was meant for the human beings doing the calculation. So really back then, before the computers, the ladies, especially the ladies, took up the job of computing, which is calculating. There are no calculators, there are no computers. So human beings do the job, again, especially ladies. So if you ever see a movie about the 1960s and 70s NASA women, how come women work in NASA? Not because they have PhD, some of them have, right? But that was still rare back then. But most of them joined as computers when there was no computers, so to speak, right?
Mm.
The expansion was meant to make their life much easier to compute. So because the result of expansion is a much simpler polynomial. So right now we can handle sine theta, for example, because we have calculator. Lo and behold, calculators, the inner of the calculators work exactly by expanding. So they never actually give you an exact answer one, right? So right now we feel that we can handle sine theta easily because the calculator do the expansion for us in terms of polynomial. That means computers can handle polynomials. Just like back then, human calculators can handle polynomial. Now machine calculators and computers also handle polynomials. Something like that. So it was not just historical, it was something that the current computers also need, right? So Maclaurin addresses that. He tried to give you also a scenario where in the end, everything converts to a simple polynomial. That is the basic summary of Maclaurin expansion questions, and that is really what they emphasize on in A-level, something like that. So I just ended my summary. Did that make any sense, considering what you studied?
Yeah.
Okay.
Yes.
So that topic is the non-exact topic, the non-exact topic. So they will put a lot of emphasis on that, right? So when the time comes, we will go back to that, and then we will train ourselves to approximate everything into simple polynomial.
Okay.
And I guess that's it. Okay, so glad you didn't miss that part. Now, the last time we met was DE, right? Then you
I think we were doing complex numbers already.
Oh yeah. We started to do that, and I was telling you to handle certain complex number using A plus BI, right?
Yes.
And then your teacher will have a tendency to give you what they think is a very practical advice. Please don't do A plus BI and C plus DI. Too long to solve. Whether that's actually longer or not, that is really depending on each person. However, there are certain questions where they specifically insert the phrase without using calculator. Then we have a practical problem. We cannot solve for unknown for equation.
Yeah.
So it's their way of forcing you to do more than just simple substitution. Right. That's the part that we didn't cover, and that should be covered by doing tutorials anyway. So no worries about that. Okay. I also want to revise one thing. You do notice that complex do the rationalization, right?
Oh yeah, yes.
Bottom one is A plus B, A minus B, in the sense of A plus B, IB, and A minus IB, right?
Yes.
So the only weird thing is that you will end up with an I square, right? Because of the, A square minus B square. So I square is -1 instead of 1. Therefore, instead of ending with the A square minus B square, you end up with the A square plus B square because of the I square. Am I making any sense?
Yes.
Right. That's the only quirkiness that you have to constantly pay attention up to A level. Right? I was finding my mistake using complex, and I have no prior experience on how to use the complex number function in the calculator, right? So I find my mistakes manually. Well, guess what? The I square was part of one of my mistakes. Oh. I still do that mistakes even at level, right? So that's just something we have to pay attention to because it will never appear in other topics. It's specifically complex, right? That's all. That's all. Okay. The good news is if you want to confirm, you can. So that was our that was half of the A-level complex number. The other half is that you use a totally different technique. I think that technique is more interesting, but it will seem new, right? So for the next 12 minutes, let me try to cover that if there is no other objection. Right. Okay, so
Okay.
I will go to your Jamboard then. Because after we cover that, you can actually. Oh, you don't have the tutorial question, right? You don't.
Oh, yeah, I don't have.
But you might find yourself able to do the A-level questions already. It is not a very they don't try to make it very complicated. Ooh, how come I put? Oh my goodness! I opened Kyoko's Jamboard. Oh, your last Jamboard is page 20, right? Is that
yeah.
Is that the no, there was DE and then still DE.
I'll make another one.
Okay, so there isn't a record on the complex one. Oh, there is. Last week. Yeah. Okay. So you see me transform a Cartesian complex number like the A plus IB thingy into another form, and then it's going to be very obvious when do we use that form, vice versa, right? So you give me a random complex number, please.
Wait, what do you mean?
Random A and a random B lah. A plus BI.
Oh, 2 plus 7i.
Right. Whether you write 2 plus 7i or i7, that's a matter of preference lah. So it doesn't matter, right? So 2 plus 7i for visualization purpose, you can actually draw this lah. So this is your 2 and this is your 7. 1, 2, 3, 4, 5, 6, 7, and like that. So there you go. That guy is 2 plus 7i, look, right? That's it lah. This guy is 2 minus 7i. Easy to see, look, right? Yeah. If you ever have minus 2 plus 7i, there's that lah. So minus 2 plus 7i, and then this is your minus 2 minus 7i. Again, obviously the imaginary part and the one with I and the one without I cannot mix, so they just decide to make it a coordinate system for visualization. Okay.
Does that cross the origin?
Yeah, there's an origin. The origin is, I guess, 0 plus 0i.
Oh, okay. No, okay.
I'm just drawing a line that kind of goes from origin to that point. I mean, a point is just a point. There isn't supposed to be a line. Nor are we very interested in a line in your syllabus. They had it like 4 years ago and then they take it out. So we are not particularly interested in the line. I'm just drawing the line for a reason, soon enough. So again, I'm doing it as a point, right? 2 plus 7i, 2 minus 7i. So far so good, yeah?
Yes.
Now I'm gonna change visually, I'm explaining this a very short way. Your teacher will probably explain longer. So this should be obvious. The length of this line, which is the line from the origin to that point, that line is obviously root 53 line, as in the length of the line, right? That's obvious, right?
Yes.
And also, if I were to focus on this theta, just like how we would focus on a trigo question, for example, right? Obviously, 2 is, root 53 cosine theta, right? Obviously, right? And 7 will be root 53 sine theta, obviously, right?
Yeah, yes.
So that's basic trigonometry, really. That's all. I'm just having a triangle there, 2, 7, root 53, and if I apply cosine and sine, okay. So I guess to nobody's surprise, I can go and find the theta lah, to nobody's surprise. I can if I want to, right? It's very simple, man. I'll just take this second guy, I'll take this first guy, 2 divided by 1, no? Right? And then I will definitely find my 2 over 1 is 7 over 2 is equal to tangent theta. This feels a lot like back then when we were doing R formula like in trigo. But the point is, it's very simple trigo. What's going on here? And then I can find the theta, right? Okay.
Yeah.
So I sneak in my root 53 and my theta, right? So if I put it another way, if I have my theta and my root 53, I will be able to arrive to this point. Just the same way as I arrive to this point by drawing 2 and 7 here. Just but to you, it will seem very complicated because why would we need to do that? We already have 2 plus 7i anyway. Why bother finding this length even though we can? And why bother finding theta, this theta, even though we can, right? So the answer is, I'm actually going to bypass the answer for now, right? Going to bypass the reason for now. I'm just going to do this like this can change into a form, a very weird form, like this. A Cartesian form, which is by nature plus and minus, into a, you call it the Euler form. Euler form. He will explain why you can do this, but you can do this very easily, very, very easily. The length that you found, you put in front, and then the theta that you found also, you put it on top here. On top of who? This e to the power of I something, which comes out of nowhere. Right? They will explain this with expansion, right? Not gonna do that here, right? My point is simple. I can change this form into this form. And just like that, certain questions become very easy. Okay, that's all I'm saying, right?
Okay.
The transformation, if you seem to feel familiar, it is because it is. The only thing that is not familiar is the e to the power I something. Why the heck is that thing here? If you could just accept that for now, until the explanation comes, nothing else feels new, nothing else. I mean, except for the transformation. How can we do this? Well, again, that's part of the explanation, right? Now, so I'm tempted to just put a A-level question, right? A-level question can sometimes be easier than your assignment question. So it's not surprising that you could do it now. Right, so let me do that. I guess that's not the hardest one. Let me try. Okay, so at page 2 on oh, I cannot see that. Okay, so that's an N. So do you know what the star means? The star?
I can't really see what those are.
Right. So they give you the Z, so no surprises. No mystery there. The Z star, they call it the Z complement. The Z complement is something very simple. The Z complement means coming from the Z is going to be this guy. So visually, this end up being an important visually, but they take out the visual side of the topic. So it becomes a curiosity. So the point is, if this is where your Z is, let's say, then the Z complement is that mirror image on top. Right? It goes both ways. If this is your W, then your W complement is your mirror image down there. Right? Why is this important? Back then in the syllabus, it ended up being important. Now it's just a curiosity. So voila, complement. Okay.
Okay.
So Z complement is just like that, right? Zn will be particularly difficult to handle, though. Now, first of all, is n. We don't even know what n is. So how can I even expand this if I want to? If I'm expanding this guy, I am sticking to the Cartesian form, right? If I quadratic or cubic it, I can do that. I can do that just using normal rainbow, and I will still end up simplifying it into an a plus bi form, right? But the n is giving us problem. And if the n is bigger than 3, it's very tedious already. Okay. So now I am going to, okay, the z is here. So for the sake of, like, that's your -1, and then here's your √3 Root 3 is around minus root 3 is around minus 1.7. So there you go. So that is your z. So that's your z star if you ever want to visualize that. Okay. Now you will notice that they will give you special angles to work with. This is obviously a special angle. Right. So 1/√3 right? 1/√3. Do you recognize what that angle may be?
I will have to draw that out.
But yeah, you go and find that special angle, and then yeah, let's see where do we go from there?
Tangent 30.
Yeah, there'll be 30 and there'll be 60 . So this guy will be 60, right? That guy will be 60, right? According to Trigo, this is still your 0 degree. So we'll call this -120, right? I'll call this -120. Suppose you can now call this +240, right?
Yeah.
Okay. So in complex, we purely use degree. So -20 degree will be equal to minus 2 pi over 3, I think. Right? Which is the same as positive 4 pi over 3. Okay.
Okay.
Now, just like that, just like that, I will now convert this Cartesian form, they call it Cartesian form, I guess, into the Euler form, right? 2, you know where 2 comes from, you found it for me, e to the power of the weird thing. And then here, either I put 4 pi over 3 or minus 2 pi over 3, it doesn't really matter. It matters somewhat when they define the range. So let's say they don't want they don't want more than plus pi. So you just have to use the minus 2 pi over 3. No big deal, right? So I'll use the convention. It's not that plus pi over 3 is wrong. There's nothing wrong with that. But sometimes I stick to the range, right? If they ever give you the range.
Okay.
Right? Okay. And I have just I have just changed the form, right? For, I hope, very obvious reason and very obvious advantage. I can now handle power very, very easily. Right? I don't know where this will go, but clearly I have handled the power just like that. This is the principal advantage of Euler formula. Can handle power and root very easily. So far, so good?
Yeah. Yes.
You will notice that once I convert the z into Euler form, converting z complement is also going to be very easy. Right? So would you kindly convert this z complement into its Euler form?
Does this question have a range? No, right?
I'm so sorry.
Does this question have a range? No, right?
It does not. And so therefore you can use whatever you want, right?
Okay.
So the length is 2, right? Same thing. There's no power n here, so you don't do that.
Oh, all right.
It's just z complement. So 2, there you go. And then e to the power of I, that's a weird thing. And then the angle will be, in this case, positive 2 over 3 pi. And we have successfully converted that. Now, z complement divided by c to the power of. I did say that the Euler form, first advantage is in power and root. Well, it has also big advantages in multiplication and division. I would very much rather divide this with that rather than divide this with this. Clearly. Dividing this with this is a simple matter. Very simple, in fact. This guy, right? The result will be. What's the result? Well, 2, 1 minus n, right?
Yeah.
That's the front. And then it's still going to be EI, right? Correct or not? Still going to be that.
Yeah. Yes. Wait. And this answer.
Minus, I guess. Minus, and 2 pi 3. Which means it's a plus, right?
Okay.
Because in this lens itself very well to division, right?
Yeah.
Once I do this, then I can start to answer what the question wants. The question wants a set of value of n for which this and this is free. I have to explain that a little bit more. But before I do that, I hope this process already shows you the Euler formula. And therefore, it rewards us for the effort of transformation. I mean, the transformation itself is not even particular, but the advantage is what we change, right? You also notice that they will not tell you to convert to Euler form. That means the knowledge of the advantage of Euler form is largely what we're trying to learn. They will almost never give you the Euler form. They always give you the definition. That's safe.
Okay.
So I'm going to stick with that for a while before we go to, so what does it mean by purely imaginary yet data? It's not complicated, but I want to focus on this conversion lah first. Ainesh, I can see you, yeah? Let me give Keiko a question to try, and I'll get back to you very quickly. Right, so let me just do that for you, Keiko. That's Oh, my goodness. They give you the exact same thing, isn't it? This comes from another school, and then, oh, this school is at least nice enough to ask you to convert. Right? Look at the structure of the question for these two different schools. They are almost exactly the same. One gives you more marks, 5, and he even tell you to convert it to exponent form. My goodness, even the number is the same. What is this? This is right. What is this? Now, I'll give it a try. The thing below is just slightly more complicated. I think you can handle it. Okay. Right. So please try that. Right. So Ainesh, yes, I can see you. Can you hear?
Oh yeah.
Let's start with our routine, which is your homework.
The thing is, I won't have the video till maybe a bit later in the tuition, but I have the iPad, so I can take a picture and then we can look at it in general, if possible.
Yeah. So what's happening with the video?
I forgot to charge the phone, so it's in charger.
Right. Come, let's discuss the question. That means use your gem. I mean, I sent you a tablet for a reason, right? The most important advantage is taking picture. Take everything. Everything as in put it nicely and separately. Take everything and then we'll discuss immediately. Okay. I want you to move fast.
Wait, how old is the tablet? As in, like, which charging plug does it use?
The shape is obvious. It's USB-C. Now, do you have USB-C?
But it said that charging is slow. You should use the most suitable charger or something like
that. Any fancy or standard charger is not going to ruin the tablet. It's going to be fine. Anything is fine.
Regular USB-C.
I'm sorry?
It's just a regular USB-C and it said it. I mean, it did charge, but it was very, very slow.
The charger that you're using, okay, you cannot show me, right? So first thing first, if you really want, you take a picture for me of the information in the charger, which is a very small letter, right? If you could do that and take a picture, might as well learn some physics. Right. Now, additional equipment means you have to charge. You remember to charge lah. So, I thought I account for that, meaning the additional trouble should be worth the advantage. If that is not true, then we'll know very soon. Should be. So, take your pictures. think Keiko, I'm a bit slow.
Okay, I'm done.
So once you're done, okay, good. Once you're done, you at least tell me, yeah?
I put in one.
You put it up.
I think maybe do one question first, and if it's troublesome, I'll just put in my phone and then I'll put a power bank.
Okay. All right, okay. Right. So I'm going to do the movement. This is a polynomial question, and you discussed this question with Kakak Brian yesterday.
No, right? I discussed this with you.
You discussed this with me? Oh, that was the first question, right?
Yeah.
Okay, so we discuss our plan. Long story short, you're going to use the vector theorem. First thing, okay. The remainder theorem, second thing, okay. Right? And then you're going to do long division. I think this part seems fine. And the 0 is a very good sign. So therefore, you have the result, which if you use the calculator, you can do this easily. And then you have all that. And then the factorization is complete. And then I guess that's it for part 1 and part 2. Right? Now for part 3, tell me what's the question again?
Hence solve the equation.
Hence solve the. Oh, from here you could jump to here or there. Right. I'm not sure what's going on. This looks correct. Oh, no, I get it. They give you a slightly different equation. You're supposed to solve a slightly different equation by figuring out how did the first one supposed to help you with the new one, right? Okay. Right. So let's say the first one you did wonderfully well, right? And then I'm going to do a comparison between the original, this guy, and what you're supposed to do, right? So notice that this is 2x cubed and this is 16x cubed. There's a clear difference. I'm going to continue. And that plus 5x squared, which in this case, this is plus 20x squared. Again, clearly a difference. And then b is a minus 14x. In this case, it will be minus 28x. And then finally, minus 8 equals to 0. And this one is minus 8 is 0. About the only thing the same is this one, right? Now, I am going to make a comparison.
What comparison?
Here you go. It is as if the original one has x, and it is as if the new one has 2x in place of x. As if.
Is it like, it's a bit, yeah.
Okay, making any sense?
Yeah, but
right. I go further to prove my point. Again, this is just x. The original is just x. It is as if the new one is plus 5, 2x squared. So 2x in place of x, right? In place of x. Last one. Just x cubed, right? So, it is as if, what? In place of x.
It is 8.
I know it's 8x cubed. Yeah, that's not going to help us if this is 2x and 2x. It's not helping us. I never mentioned this as 4x, okay? Pay attention, yeah? I never mentioned this as 4x squared.
So it'll be 2x cubed, yeah, 2x cubed.
2x, everything cubed, which you will get your 8x cubed, right?
Yeah.
So it is as if the first guy is x and the second guy is 2x. And it goes very consistently. If this is very consistent between, the three things, then we have discovered the mystery, the comparison between the first guy and the second guy. Therefore, without using the calculator, that was your question, right? Without using the calculator, this was your origin. Sorry.
Hello? I can't hear you.
Yeah, so originally it was like this equals to 0, right? Originally, correct?
Yeah.
Then instead of x, I put 2x now to solve for the new guy. Therefore, in this case, I have x equals to 1 instead of x equals to 2. Do you see that?
Yeah.
So this guy leads to this guy. The reason is because I replace the x with 2x. Now, try doing that for the two other solution, replacing the x with 2x and see where that leads you to.
Okay. Slowly.
Keiko, how is it?
I managed to convert it.
Okay, let's see. Yeah. So obviously your P is, okay, you already know where your P is going, right? That's obvious. Yeah, you can use 4 pi over 3 for now, and then the P thing definitely, and then power n also definitely. So the issue is with the I times, right? The I times, this is something I haven't taught you, right? So I times P, you can see it multiple ways. First, we'll do the long way. I times P is very easy to understand. You just have to times I everything up, right? So we don't deal with IP. We deal with, so what is IP, right? Again, it's very simple. IP is simply minus I, right? And then √3. Do you know why?
Yeah. Then what?
So I basically just take the original and times I, that's all. That's all. So like the minus I comes from -1 times I, obviously. And then the √3 comes from minus √3i times I. I square is -1. Hey, I have √3, that's all. This is the
yeah, okay.
That's all. That's all.
Okay.
So I would deal with this rather than IP. This can be converted to a proper Euler form also. Very easy. So I challenge you to do that first. Very simple stuff, right? Okay. So Ainesh, no movement. No movement, nothing, right? Ainesh?
Oh, sorry, you want me to do it on the Jamboard? Oh, okay.
How else can I follow, Ainesh?
Okay.
How else can I follow?
The good thing is that because I don't have to do it under the stand, then I can just do it in a comfortable position.
Which should have been like that from the start, as in the arrangement should have been comfortable, right? So hearing that makes me wonder how to make you more comfortable, right?
And I don't think it's possible, honestly, but it's okay.
No, it's not okay. Everything becomes slower. And to you, having more speed is important. We'll talk about it later. Come, do it in Jamboard first. The writing might be a bit annoying. So Michael, I can see you. Can you hear me? Right. I cannot hear you. Sorry, I cannot hear you, Michael.
Yeah, hello.
Okay, much better. Sorry, I didn't see you. I probably didn't see you come in the first time. Yeah. Do you have any question? I guess that's a very important thing.
Well, I don't think so. Well, none that have not been clarified.
True. So good to know that the answer key is working fine, right? Good to know.
Yeah.
So like that and like that. So you see now you're getting more of the answers. So Michael, there is nothing to today, right? Even though Windows is just moral support, but in MCQ, as I have promised, it's not difficult to study for MCQ if you're motivated, because you have enough time and enough guidance, right? That's why most people don't need tuition for MCQ. So tomorrow, is it tomorrow? Is it tomorrow? Tomorrow is your chemistry, right? Morning, correct? Am I
Yeah.
correct? Right. Okay. So your second morning paper, what do you think? Are you going to be okay?
My second, what?
Like your first morning paper is what was that?
Oh,
SS, is
yeah,
it?
I think
SS,
I think
right?
it's gonna be fun. Yeah.
Right. Good to know. Good to know. You know, and then I'm still recovering from COVID lah. So today I did my morning paper for what they call H2 math lah. H2 math, A levels lah. Same thing as the A math paper 2. A math paper 2 is when I start to have the symptom. Right now I'm still recovering. Alamak, there's so many things I want to do and I'm just super slow. Now I'm telling you this because therefore I'm very clear that having a good body and having a good sleep is gonna be a very positive effect to your exam, right?
Oh.
My goodness, yesterday I also cannot sleep. Didn't expect that. So my goodness, today I want to do things fast. I can't do things fast. My brain is stuck. Still can do lah, but definitely my percentage will be lower than if I could do it faster, right? Very relevant for MCQ, right? Surprisingly, MCQ is definitely a crunch time, definitely, right? I don't think you can say with confidence that you finish everything in 1 hour. Hopefully you can, but it requires a lot of thinking. So if you're going to sleep well and tomorrow you're going to be fit, then I think that's what
I think that I better sleep now because usually I have
Yeah.
problems sleeping before exam day.
Correct. Why don't you do that and wake up earlier, and if you want, then study more? Why don't you?
Sure. Well,
Right.
yeah, okay.
Right. Okay. You sure? Huh? Right.
Yeah.
That's what it is. Then I will always have tuition tomorrow for other people. If you want to show up, then just feel free to show up. Right. Okay.
Sure. Okay.
All right.
Yeah.
All the best, Michael. Bye-bye.
Thank you. Bye.
Right. So, Ainesh, from now on, polynomial questions will include that last part, the part where we pretend X is something else. We just have to discover what it is. And then this is how you do it without calculator. That's all.
I see.
Your calculator will be very useful to confirm, but if it is paper 1, then you don't have that option, right?
Yeah.
Right. So you can get the last 2 marks. It's never 1 mark one, it's at least 2 marks. So I guess that's another good thing. Right. The technique is what I've explained here. And then the technique will also appear from time to time in other topics. Right. Right. Okay. If you have no other question, then let's get to the next thing, which I see in page 16. All right. Can I make it bigger for you?
Yeah, my mouse is glitching. It's not.
So let me do that. Okay, yeah. So let me check Keiko first. Right. Okay.
Is it clear now?
Yeah. So Keiko, with that in mind, you can have. You already learned how to handle it, right? Okay. Yeah. So what is left is the purely imaginary number. The purely imaginary number basically means that the angle will be either 90 or minus 90. That's what purely imaginary number means. You know why? Because purely imaginary number lies on the y-axis, right? Which means it's going to be 90 or minus 90. So, right? So you're going to set this angle into equals to 90 or equals to minus 90. So more appropriately is, that's the 2 smallest positive whole number. Done lah, finish. That's it. That's all.
So it's
like this whole thing
only
equals to
purely imaginary is just like that, right?
Yeah,
doesn't have a thing in front. Okay, I see.
I guess that makes sense. That will result in a 90 degree or minus 90 degree angle. Again, the visualization does help a lot, right? It does. I wish when they study, they use it a lot. I wish, right? Not very difficult. And that's it. That's 5 marks for right?
Oh, okay.
Right. You can practice that And then maybe you go to some prelim questions and then you just fish out some one or two. There are another type. It's not very difficult to understand. Okay. So Ainesh, so I see that you are stopping at, oh, wait, that's interesting. You found the X, oh, you found the X and the Y, right? So good luck, right? And then the bottom one, you also found the Y. So you're saying that this is okay. You're saying that the first one is okay and the second one is okay. That's what you're saying? All right. Now, your only problem is this. Is that what you're saying?
Yeah, that's a different question. Wait, is 4B saying hence? It didn't. It's a different question.
It is. Now, you commit an error in your second line. Find that error first. Find the error first. The rest of the technique actually looks great to me, but you make a mistake here. So again, please find your mistake. It'll be good to find your own mistake.
The 2x minus 2 is not 2x by 2 by 2 to the power square.
No, that's correct. You are guessing too much already. I don't like it. You say something correct to be wrong. I don't like it. It feels like you're guessing things. That means you're not confident with your English. Right. So a slight confusion here. How come it's -1 over 8? Because -1 over 8 is obviously not a whole number. It's also not positive sum, right? Yeah. I don't think you did anything wrong. No. Oh.
Also, what do they mean by, like, the previous question asked for range, right? Then this one is two smallest positive. So do we like use the different angles?
Yes.
Oh, okay.
Yes. Because 90 degree. No. The 4 pi. The thing here is okay one. That one no need to change one, right? But equal to 90 degree does not always mean equals to pi over 2. It can be
negative. The negative.
No, I guess so. But if that also doesn't work, I'm guessing that won't work also based on what they are asking. It's very simple one. 90 degree is equal to 90 degree plus 360 equals to 90 degree plus 720. You keep doing that until you get your smallest positive number.
Okay.
That's the long method. I'll show you the shorter method. But now do the long method first, so that you understand. Okay, Ainesh? I mean, I make it very blatant that the left-hand side is correct. So I am not okay with you not spotting your mistake already. I'm totally not okay already. I'm making it blatantly clear that the left-hand side is correct.
It's 10,000.
I would like you to spot that mistake next time. I mean, better not to make it, but at least spot it. My hint is too clear. I'm not okay with you not realizing it. Right?
I got cocky. For some reason, I thought 100 square was 1,000. I had to use my calculator to find out 10,000.
So use your Jamboard, right? Put another 0 there, and then you fix until the final part, and then we'll do the final part together. Let me see the 0 quickly.
Stop sensing.
Like when the pen approaches the screen, it just you have to put the pen. You have to put the pen tool also, like pen tool. The pen tool must also be okay. Right. 0, 0, 0. Right. Okay. So since I cannot tell what exactly is wrong when you're writing, you have to tell me if something is bothering you, right? Okay. So now you want the x equal to, I agree with that, right? And you don't know how to. But the thing is, you keep asking this type of question, and I also don't feel like I like it after a while. Feels like you keep don't understanding stuff. Now you want the x equal to, right? That's what you want.
Yeah.
Okay, let me repeat this phrase. I keep repeating this phrase. I am not very happy. You want the x to go down. That's all you want.
Yeah.
You still don't get based on that here.
In order to get x to go down, 40,000
Yes.
has to be a factor of 2. Sorry, not factor, as in like
No,
2 to the square or
no,
something.
that's outdated. It's like you learn this on day 2, then you think like that. That's not true. That's a technique from day 2, not now. You're just thinking about that technique. No good at all. You never advance from day 2 of Indus. You want the x to go down. If 40,000 can be 2 power something, the x never need to go down.
True.
So to make the x go down, you have additional technique. What is it?
Use log.
Log base?
Log base x.
Come on, man. Come on. It's like you're back in day 0 in learning log. When the log base and the base of the indice inside the log matches, they both cancel each other, right?
Oh, okay, no, cannot do.
Come on, man. This is day 0 in logarithm.
Yeah.
And you keep asking this question. So x equals to that thing lah. And whatever that thing is, you leave it like that. Right? It can't be simplified. Today, I just want you to remember this technique next time.
Yeah.
Right? Now, your homework is done, right? That's it lah, correct? To be sure, you are making progress. That much is true. So I guess for you, it's repetition no? Until you finally cover every skill needed. Lah. Or rather, in this case, remember. Lah. Because you obviously have it. You obviously have it. But you don't access it for some reason.
Okay.
Right? It is not acceptable. After a while, it gets... right. Okay, Nash? What's our next homework? Let's prepare it and then let's jump to science. Come on.
Jump to third.
Science.
Oh, science. Okay.
Prepare the next homework first. Come, you know? I don't have to repeat, right? You know what to do, right? Put your homework, discuss, we jump to science. Sorry, Kiko. You're not getting the answer yet?
Yeah, it's not. I'm not getting any whole number.
So like this, yeah. So I will put the formal presentation. The formal presentation is plus n 2 pi lah. Meaning we're gonna sorry, I cannot say n, right? I should say k lah. I'm gonna keep adding additional 2 pi until I get the answer I want. Something like that. Okay.
Yeah, that's what I.
So the k is minus 2 minus 1 dot 0 1 2. Okay. So now I do the formal. So minus 4n plus 1 pi over 3 equals to pi over 2. Okay, this one will be 4 times pi over 2. Right? So 1 plus 4k. So far, so good. Okay.
Yeah.
If I want to now make all this the same, right? So I'm going to times 6, right? So now 6 minus 4n plus 1 equals to, 2, 1 equals to 3, 1 plus 4k, right? Right. So k has to be a whole number, and n also has to be a whole number. So let's see how we can do it. 2 will be 3 over 2 plus, I'm very slow, right? 6k minus 1 and then divided by 4. My goodness, I'm super slow right now. Let me see. This one is half. So this worries me again because that means this is minus 1 over 8 plus 6 over 4k. No matter what, we'll have this minus 1 over 8. This is the reason why no matter what you put at k, you don't seem to be able to get a whole number for n, right?
Yeah.
This worries me a little bit. Maybe there's something, right? Maybe. Yeah, I don't think so. Right. I don't think that you can get. Oh, you have your screen sharing. Right. Your paper. Ainesh, you're supposed to prepare the homework first. So select the questions we discuss, and then remember that's what we do. That's what we do.
Okay, I thought we were gonna do science again.
Yeah, I want to jump to science very quickly, but you still have to prepare your math homework first. Right?
Okay.
So I'll just check one more time. Okay, cool. Here we're just checking for mistakes, right?
What topics?
Oh, that is your question to yourself. That is your question to yourself. But I feel that repeating polynomial in this log and trigo is not gonna go bad. It's probably what you want, right? But you feel free to add topics.
Wait, what do you say? You cut off for me just now. What do you say?
Putting poly in this log and trigo is not gonna be wrong.
All
right?
four.
Oh, you decide. I mean, it's time to expand beyond 20 minutes. It's time to go to 30 minutes anyway, right? So you have more room to add more stuff.
Okay.
Right. You're getting better anyway, so might as well show things off, right?
I'll focus on poly in this log. I'll make one trigo question.
Sure. That would be a nice way of starting the trigo. Right? Very nice. If you're confused which trigo, start with the sketching one first.
Sketching. Oh, okay.
Yeah. The sketching, which usually have a lot of a very long word problem. That can be the sketching, right? Let's see whether you can spot that. Oh wait, no. Oh, wow. Okay. So Keiko, it's not that we cannot use minus 4 pi over 3, but I think using 2 pi over 3 is slightly better. I think
I was wondering which angles were better.
Yeah. I mean, I guess less smaller size is better, whether positive or negative. The positive or negative is less important. The smaller size will just make things easier to do, I suppose. Right. So in this case, I would totally recommend 2 pi over 3, right? Just because it's a smaller one. So you can change that. And then power n also easy to handle.
So this would be okay.
I'm checking the below one. There seems to be something wrong with the bottom one, right? Okay, that's okay. I'm gonna check the bottom one. So it seems wrong. What's going on here, right? So you're saying that this is that. Let me think for one. This seems fine though. All right, so now look at this. If this is 60 degree, if this is truly 60 degree, then this would be the longer one and this should be the shorter one. Make sense?
Oh.
Right. So that should be 30, I believe. So it's now minus 30 minus pi over 6. Maybe that's what we need. Maybe.
Yeah, okay.
Maybe. Because the minus 4 pi over 3 shouldn't give you shouldn't make it unsolvable, right? It shouldn't be. It's not a mistake. It's not considered a mistake to do that. Okay, so I'm seeing the sketching question. Good, Ainesh, right? And then log and polynomial. So how many total marks are here so far? Oh, proving. Oh, getting deep.
Tossing in one in there.
I don't mind. Let's make sure that the total is around 30 first, right?
Can you total it for me? I'm looking for one more in this question.
No, you total yourself, right?
6 marks left for 30.
Very good, very good. Yeah. You forgot the n, Kiko. The n, there's an n there. Oh, but you mean that's the n now? I understand. Right.
Yeah.
So at this point, I guess you can try. Wait. This needs to be equal to. Wait. Yeah, no, right. Yeah, no, you don't do n like that. You're saying that this is equal to. This is basically yeah, the pi over 2 lah. So you constantly change the pi over 2 so I don't think the pi over 2 will work, right? So then you change it to 5 pi over 2 and then you change it to 9 pi over 2, something like that. You keep doing that.
How many times should I be doing this?
Until you get it. Until you get it.
Okay.
Do you have the last 6 months?
On in this one, so I can do all 4. Can't find one though.
In this one always have, you know, the word problem, the long one, that long question. There's always that. Don't miss that.
I've gone back to 2013 and I still can't find it. It always has to do with log. There's always log itself.
The in this word problem, the in this word problem. Don't forget that there's a in this word problem type question. The one with long stories.
Yeah. SJ usually doesn't do that. SJ usually don't do that. They go straight to the point.
No, the past 3 papers we did always have that.
Did they? Okay.
Stop saying conclusive stuff. That's what you said is not correct for the past 3 years. We started off with those kind of questions. You keep saying that they don't exist. That's not true.
What does a modulus do?
No. If you haven't learned modulus, then don't.
I put in a modulus thing and also in. Did I?
If you can, I guess you can treat it as a new topic, I suppose.
Oh no, I didn't. Okay, never mind.
Not too long, Ainesh. Not too long. Not too long.
I keep getting a 0.5.
Okay, cool. So I'm gonna erase all this first. Okay. Yeah, there's nothing wrong there, right? Half minus is 1/3, right? 1/3 plus 2k over 2/3 equals to yeah, you're right. At this point, it feels that the half is now bothering you. So that's not surprising. Yeah, what's going on here? Ainesh, if there is no other question, then for now, why don't we just discuss this question first? More like you read the question first, and then you target, and then we discuss any problems you have, right? Standard stuff we do every day, right?
I'll just put in a polynomial. I can't find any in this, so I'll spend 2 hours.
I suppose, right? Let's do that, right? So start reading, and we'll discuss the problems that you imagine may happen.
So for the first one is given the y equals to 5 sine 2 x plus 1. Okay, 5a shouldn't be an issue. That's actually 3 marks.
Then target the mark. Target the mark.
5b. That's sketching. Okay. I actually don't think I'll be able to get all 3 for this. I have to check my notebook first and then do it. This will take me some time. And then hence find the number of solutions. And that's where the modulus was talking about. Yeah, I don't understand what that means. I don't understand what 5c means.
Okay, you circle your problem first. Yeah? I'm still trying to find the mistake for. Okay, cool.
Everything.
Yeah, correct. There is no mistake. I tried to find the mistake later here. Right? We try not to get the answer key. The methods are fine. Though. The methods are fine. So there must be a mistake somehow, right? Why don't you look at another prelim question? It's very easy to spot a complex number question. And then perhaps after you try that, we'll just end our introduction to complex so that we just wait for your tutorial. I think that's a better way to do it.
Okay.
Right? Maybe just fish for one more. Fish for one. When you found it, you tell me. Yeah. Right. Okay. So the end of reading, Ainesh, is your targeting. So once I see your targeting, I know what you're thinking, I suppose, right? Okay.
Yeah. Okay.
So let me see your targeting, and then we can discuss the problems that you may have. What do you mean by 5 minus 4? Sorry.
It's 4 to 5, but how do you read it?
Please communicate your intention clearer to me, right? So that it doesn't take so long, right? I need to understand you quickly, right? Don't delay things. Communicate effectively, right? Let's discuss question 5 later. Now, how about the rest? Let me see your intention. Do not rush in your reading and try to understand the question so that you can spot mistakes or you can spot problems.
Okay.
Oh, you have a question. Okay, go. Quite a long one. Okay. Still make it. Goodness me. Oh, ACJC. No wonder, right? Oh, no. Okay, the moment I see locus, that means this is, this is from way back, right? So the word locus means it is out of your syllabus. This is a bit way too back.
Oh,
this is
okay.
Too much way back, right? plus, no, this is actually fine. That's actually fine. The one you can handle, but never mind. Don't try this one. Don't try this. Because the rest of the question then cannot do much.
Wait, but then in like one of my recent Nanyang promo papers, right, I saw the word locus also in vectors.
Could be parametrics or vector, right? So they take out the drawing part. The locus is the trajectory, the trajectory of a point, right? So another function. They take out function, drawing, trajectory from complex number. So it's not the word low. It's not the trajectory per se. Yeah, other topics I think can.
Okay.
So Ainesh, for A, do you think you have a problem?
No, I mean it's gonna be base changes I'm not very comfortable with, but other than that, no.
Okay, then targeting to declare your intention.
I'll say 3.
Okay, but I totally agree with the base change. I totally agree with that. Totally agree.
Okay.
How about for B?
For B. Oh, I have no idea.
Right. Let me repeat. This is the second time I repeat. Right. This is clearly an in this question. Right. When an in this question have positive down there, positive or negative, so plus or minus down there, not up here. Up here, no problem. Down here, positive or negative. When this happens, it is a very clear sign for the technique let or sub. Do you know what I'm talking about?
No.
Just like last time, right? Just like last time, right? Let something equals to y. Sub this as y. Triggering any memory?
Not really.
Okay, one more time. You see the indicator. Repeat the indicator for me. What's the indicator?
Plus.
Plus or minus, be complete. Where?
In logarithms, it becomes multiply. In indices, it doesn't mean it.
Stop concluding that. I didn't say that. I didn't say that. Not yet. Not yet. At least absorb what I say first. When there is a plus or minus, where in this?
Oh, it becomes multiply.
Where? Where? No, I didn't say that. When there's a plus or minus, where in this?
It'll be
down there. When it is a plus or minus, down there. Do you see my circling?
Yeah.
When there's a plus or minus down there, what did I say? At least repeat what I say first, at least.
Okay.
What should you do?
I should try to change the base.
I don't say that. Oh my God. I say use the technique sub or let.
I'm missing something. I don't know what that technique is.
This is from your school, right? You are missing something. When you see the sign plus or minus down there, use the technique sub. In this case, sub 3x equals to 1.
Oh, okay.
You try to do that. This is not a fringe question. This is standard question.
All right.
Okay, give it a try and give some targeting.
I'll say 3.
All right. Moving on. Oh, a graphic calculator is not.
Oh, 7 a graphic calculator.
No. That's your senior. That's your senior. Whoa, that's going to be troublesome. So, Keiko, whenever you see cert with an imaginary number inside, that is going to be very troublesome. That is usually avoided. That's usually avoided like a disease, like COVID. It's usually avoided, right? Okay, so yeah, I didn't expect us to encounter this, but okay. So we encountered that in 2015, right? Let me think carefully first whether you still have it right now. Yeah, no, so don't continue. Yeah, don't continue. You have no appropriate technique to handle with the imaginary number inside because when they convert to Euler, usually that's how you handle it. But this guy, when you convert to Euler, is going to be very ugly. So it's not going anywhere. It's really not going anywhere, right? They are aiming for a nicer number, like in this case, right? So you do have the technique, which is the Euler thingy, the transformation thingy, but it's probably not going to give them what they want. So I guess the only technique you have right now is this. The only technique you have right now is this. Yeah, let's just use what you have available, right? So this is what you have, right? So right, this is not a surprise that I write this, correct? It's not a surprise at all, correct? Yeah, that's the only technique you have. You do that and then you compare coefficient.
Yes.
Does that make sense? What I'm doing?
Oh, okay, I see.
Just remember, you still have it here. You have that.
Yeah.
So I'm just using that there. So that's already helpful. And then this one comes into mind.
Okay.
Right. Ainesh, okay, I have to drive you forward there. So 7A, what is your problem?
7A, okay. I tried to look at your previous solution because you solved the question without calculator, but that's because you had a reference to a previous.
Correct. So that's not going to work here.
That's not going to work here. And
that's going to work at 7B. 7B is going to do it like that. 7B.
Okay, 7B is okay, but 7A is a 5-mark question. So it's definitely
without calculator, right?
Yeah, for sure.
Right. So yeah, you have to solve this, and it is possible to solve this without calculator, so to speak. So are you positive first that this is non-calculator?
I mean, it's in paper 2, so it logically means you should use calculator, but
you should.
5 marks, so it's kind of scary.
No. Use calculator. No, use calculator. What are you talking about? Are you saying that you don't know how to follow up from your calculator?
No, I know how to use it from the calculator.
No. How to follow up by using the result of the calculator. You have to do certain things to make it acceptable. You cannot just say use calculator. Right. So now you press your calculator immediately. Just now. We're just going to do this. So use it, and then I'll tell you how to present it. Give me the answers from the calculator first.
Okay. X equals to -2.
Right. That's -2, and then
2 and
2, okay.
half.
Okay. Let's focus on the nicer number, -2 and 2, right? So you're going to simply do this. Based on your calculator, I have the information x equals to 2, x equals to -2. I'm going to start with x equals to 2. You're going to sub x equals to 2 out of nowhere. Out of nowhere, that's what you're going to write. Sub x equals to 2. And then you're going to sub it into the function. And then you're going to discover that that equals to 0. That's factor theorem. No? You basically, out of nowhere, present x equals to 2 as your own guess. Even
so
though
it's
it
guess
is
and check.
informed, it is guess. It has always been guess and check. Back then, when we really don't have calculator, we do guess and check. Check 1, check -1. Check 2, check -2. Oh, 2 is okay, right? Okay, good. That's it. So now, by the information of calculator, your guess and check has become not guess and check, but you still have to present it that way. You understand me?
Yeah.
Right. So present that properly, and then you can solve everything. No? Okay.
Yeah.
Do you think you can get the 5 marks? Because I know you have all the knowledge, judging from your previous work.
No, I don't think so. But I think maybe 3. Cause I mean, I've never.
What's the problem? What's the problem? Sorry. Now, after you sub x equals to 2, and then you check everything is equal to 0, you encounter the first factor, look, correct? X minus 2, right?
Yeah.
So what do you do after that? What do you do after you have a valid factor, basically?
Wait, so if I have a valid factor, for example, say x minus 2, right?
Yeah.
Then do I put it in like a regular long division, find out what the division is, and then
quadratic, and then proceed normally from quadratic, correct?
Okay.
Correct. And that's why they give you 5 marks, I suppose. It is still a lot of work. It's easy stuff, but a lot of work.
Yeah, okay.
Okay. So can you please get the 5 marks?
Yeah.
Okay, good.
That should be easy. And then 70, I'll target 2. I have reference, so I'll target 2.
Correct. Do the proper technique, and then you should be able to secure it.
Okay.
Oh, you got it, Keiko. You did get it, isn't it? You did get it.
I'm not sure if this is correct.
I can just check the answer.
Yeah.
It's a nice number, so I guess that's already good.
Okay.
Good. Now, how about 11? I mean, there isn't much to comment. You want 11? You know what's cosecant? Do you know what's cosecant, Anish?
Oh, you're speaking to me. Oh, yeah.
Do you know what's cotangent?
Yeah.
And if you see 2x and 2x, you probably need to use the identities. You don't have to memorize the identities. You can have it in front of you. Do you know that?
Yeah.
Okay, so use that to your advantage. You will need it. You will need it. You're probably rusty anyway.
Yeah.
Okay. If you have more questions on the proving one, I'll try my best to help you without giving away.
It's impossible to try to do it without you putting my pen to paper.
True. That is the nature of that question. True. Now, the last one. Okay. All right. Let's see how near you can go. Let's see how near you can go.
Consider the function. Effective x cubed and such.
I think the first 2 marks is easy, right?
The rest was modulus, so I just took the first.
That's already good for 2 marks. At least we try to obtain that. And this is calculator. I think it's better if you can use calculator.
Okay, so this is quite easy. This has to be easy 2 marks.
Correct. I mean, they do give bonus marks. So I don't think this is useful for homework, but you have already selected it. You don't have to go back. Maybe next time, just select a harder one. Maybe next time.
Yeah.
That's fine.
Okay.
Right. Is your homework slightly more challenging and therefore potentially more useful than yesterday's homework?
Yeah.
Good. That means you're doing the right thing. You are doing the right thing. Right?
I'll see how proving goes. Sorry.
You're saying? No, you're saying?
I'll see how proving goes, and then if I'm weak in it, I'll do more proving tomorrow. I think I'm gonna be weak in it because I was never strong in proof.
Correct. But if you have motivation, I wouldn't stop you. It is good for practice. It's just not good for marks. But it is very good for practice. It affects every other 3 goals. That's why I support you trying it out. But don't try it at first, okay? Maybe you want to try it as the last question. Because you have a time limit, you see. If you want to continue after the time limit, then at least note that before the time limit, you cannot get it. At least you know that. Right? You always have time limit, correct?
Yeah.
Right. But I'm glad that you choose to try to do. Any other question for the homework?
No.
All right. Then we are free to do science. So, is it? A little bit wrong? Is it, Keiko? Really?
Yeah, I found a mistake. My pen just died.
Right. It's just manual. I mean, it's just simple math mistake, right?
Yeah, I just missed out on this one.
Right. Techniques-wise, it should be fine. Yeah, technique. So this question is purely your first technique, right? We can say that.
I guess, yeah.
Even until A level, the technique still remains, I suppose. The technique still remains. Yeah, let's not bother too much about. Let it not bother you too much until the tutorial comes in.
Okay.
Right? The moment the tutorial comes in, you can probably do everything already. Right?
Okay.
Right. So yeah, for your 2022 complex number, it is a short topic. Okay. Now, what is your next topic? Do you have something in mind?
Hang on. I have a list of topics, but I don't know which order are they gonna teach the topics in.
You can tell me a little bit. Okay, Nesh. All right. So you switch on your screen sharing, and then let's go to the science one. We only have 20 minutes, so maybe we will satisfy your curiosity on chemistry first, maybe.
Okay.
Right. You're gonna ask me questions based on the slides, right? Okay, you're gonna clarify the slides first.
Yeah.
Okay, according to the list, the first topic for statistics is permutation and combinations.
It is. It will seem totally new. So unless we're jumping to statistics, we try to avoid. Oh, you're saying that there's no other topic.
I guess not. Other than applications of integration, but it's applications.
I guess there's nothing wrong with jumping to PNC, but PNC is highly dependent on tutorial also. Would that be a bad thing? Try your best to get some lecture note. If not, then we'll see what we can do lah. I guess. But I understand. Right. Yep. I mean, we can end today first. No need to go further. Sure. Okay. I'll see you on Thursday then, right?
Yeah.
All right. Okay. Bye.
Bye.
Okay. What is your question for this slide, Ainesh?
Do I have to memorize all this?
All right. Let me tell you what you need to memorize. Right? Not this. Okay. So I'm gonna write. No, actually, no. I'm going to tell you why you don't need to memorize that table. It is a very good question. Yeah. I am going to ask you to actually go to the reactivity series. I'm not talking about this table. I'm talking about the go down. Just go down. This. Just now you passed through it. Down again. Just stop it. They give you a very slow method, but maybe reliable method lah. Instead of memorizing potassium, sodium, calcium, magnesium, blah, 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 they give you that low. Please send camel, monkey, zebra in large heavy crate soon. I don't like the method. I prefer that you memorize it this way. Look at page 18. Now, after you memorize this, I will show you why you don't need to memorize the table, right?
If you want, I can switch on annotation.
I guess that's easier. So please do that.
Okay, then I can take a screenshot and go into the gem box.
Okay, is it that? Can I annotate it?
Yeah, I switched it on.
Okay, wait. I have to go down. Yeah. Okay. So I'm asking you to brute force memorize something that will serve you for a long time, right? So can I write here? Yes, I can. So carbon and hydrogen. First, I ask you to memorize this, okay? Okay, carbon and hydrogen. I'm asking you to memorize the order. You will soon see why. You will soon see why, okay? Yeah, your first memorization, carbon and hydrogen. So far, so good?
Okay.
3 dots in the middle, 3 dots at the bottom, and group 1, group 2, group 3. Not very difficult, right?
Do you say carbon?
Yeah, there is no carbon here. I know. I'm asking you specifically to do that. You will see why soon. Yeah, then follow me first. You will see how useful it is, right?
Okay.
Carbon, hydrogen, group 1, group 2, group 3, 3 dots, 3 dots. Simple, right?
Sure.
Repeat.
It's gone.
Yeah, I know. I cleared it. Repeat. Rewrite using annotation. Right. Right. Now, the one on top is group 1, group 2, group 3, just saying, right?
Yeah.
Right. And that's it. You have already memorized the basic structure. Now, the 3 bottom one, right? The 3 bottom one is your hydrogen. The 3 bottom one is actually very easy to memorize. It is kind of like the Olympic medal. The Olympic medal is gold, silver, and bronze, correct? All the precious metal.
Yeah.
There is therefore gold here. Gold at the bottommost, silver slightly on top, and not bronze, because bronze is a mixture of copper and zinc. So copper, copper is a precious metal. So my point is the 3 guys below hydrogen are the 3 precious metals: copper, silver, gold. Gold is the bottommost, therefore gold is the least reactive. The order has a meaning. The one at the bottom is the least reactive one, the least likely to change, the least likely to be gold, silver, copper. Can you memorize these 3?
Yeah.
Right. Now, how about the 3 in the middle? So the carbon is meant to be here. So the 3 in the middle is this one. Those 3s are very important to memorize: zinc, iron, lead.
Oh, hold on, like metals.
But not bronze, like copper.
Okay. Do I have the 3 in the middle?
3 in the middle, yes. Zinc, iron, lead. Just memorize that. Boom. In fact, the guy in the middle is iron. Iron is the big guy for the next chapter anyway, right? So iron and carbon. So we have it featured here: zinc, iron, lead. Okay.
Okay.
So group 1, group 2, group 3: carbon, zinc, iron, lead, hydrogen, copper, silver, gold. Right. Okay.
Okay.
Now, if you clear everything, you can still undo. You know this, right? So try clearing your annotation. You will be able to undo it.
Okay.
Try clear.
Take a screenshot first, just in case the undo doesn't work or something.
Right. You can put it in the Jamboard so that you don't lose your screenshot, right?
Yeah.
Okay, then clear your annotation. Clear everything.
Okay.
Okay, including your typing and everything, including that.
How do I clear?
I guess clear everything, clear all
Oh,
drawings.
you can clear my drawings.
Yeah, something like that. Okay, so you can clear mine also. You're the presenter, so you can clear mine. Clear all drawings.
There was a.
Okay, good. Now use your voice, no need to write. Don't go back to this. Don't go back to this. Don't look at this one. Don't look at this one.
Oh, don't look at this. Sorry.
Yeah, don't look at this one. So the top few metals, I never asked for you the name. I just remember as group 1, group 2, group 3, right? Okay,
Yeah.
so let's go from top to bottom. Go. Say that.
So we got group 1, group 2, group 3.
Yeah.
Then copper.
Carbon.
Sorry, carbon.
Go.
And then after that zip. So zinc, iron, lead.
Good.
And then hydrogen. And then the
Good.
Olympic metals. Copper, silver, gold.
Good. For the group 1, group 2, group 3, you just look at the periodic table. Now go back to the slide. I'll just show you first. In the slide, what they say is potassium and sodium. That's your group 1.
Yeah.
Calcium and magnesium, that's your group 2. In fact, there's a group 3 after magnesium, aluminium. Right? So potassium, sodium, group 1, calcium, magnesium, group 2, aluminium, group 3, and then carbon, and then zinc, iron, lead, and then hydrogen, copper, silver, gold.
Okay.
You shall never use please send camel, monkey, zebra in large heavy crate soon. You shall never use that. First of all, it's extremely slow. People who do this will first write down please send camel, monkey, zebra in large heavy crate soon. And then they try to decode what's P. P is potassium. By the time you decode all that, 5 minutes have passed. Yeah, it's just so slow. It's very slow, right? Please don't use it. Please, no need to memorize it. Just use what I told you. Group 1, 2, 3, carbon, zinc, iron, lead, hydrogen, copper, silver, gold. Okay?
Yeah.
Now, go back to the slide that you asked me. Should you memorize this one? Go back. Not this one. I think the one above. Right? Okay.
All of this stuff.
Okay. Okay. Look at that. Okay. Let's look at the first one. Let's look at the first one. No need to jump around. Oh, this is not the starting one. Go up. I think they're furthermore up there. No, that's very weird.
You don't have to memorize this either, right?
That one, no. At least I don't think so. I don't think you need to. So I don't think so.
Yeah.
Now, the table. They will assume that you know the table. However, the order of the table is very easy to see. Why is potassium reacting very violently, whereas sodium also only violent? The word very violent and violent does express the reality. Potassium will react very violently with water. Sodium only violently. Still both dangerous. Why is this so?
Are they in the same group?
They are in the same group. Both are group 1. Refer to your periodic table. But there is a slight memorization that potassium is more reactive than sodium. Look at the periodic table. Stop jumping around. Just look at the periodic table. Look at group 1.
Okay.
Where's potassium?
Can you see my cursor?
Right. And where's sodium? Now, what this means is that as you go to the bottom, this is a bit of memorization. As you go to the bottom, stop jumping around. Go to the periodic table. Stop jumping around. As you go to the bottom, the experimental result is, as you go to the bottom, things become more and more violent. So, experimentally, potassium is more violent than sodium, because potassium is the guy at the bottom. So that means if you go to rubidium, Rb, it is even more violent. So far, so good?
Yeah.
Lithium is more violent or less violent than sodium?
Yes.
How do we know? Experimental. Okay, experimental stuff. Let's go to group 2. Calcium or magnesium, more violent?
Calcium.
Correct. That is what you will see at your table. You go back to slide. You go back to the slide. Potassium, very violent. Sodium, violent. Going down, you will see group 2, look, right? Calcium, readily. Magnesium, very slowly.
Is there any scientific explanation behind this?
Experimental.
Yeah, but we're assuming that's a fact. So is there any scientific explanation?
If you go to chemistry year 5, I am more than happy to teach you.
Okay.
Right? More than happy. For now, they want you to memorize that somebody is going to be very violent and somebody is not very violent. But if you already memorized the reactivity series from just now, the order is the same. That is the whole point of reactivity series.
But the reactivity series just says group 1, group 2. It doesn't say this.
No, that's my summary. That's my summary. Group 1, group 2, group 3. That's why I combine it with the periodic table, saying that as you go to the bottom, it becomes more reactive. So what is the complete reactivity series? The complete reactivity series is
both the images and then
they just selectively choose some. In reality, francium is the worst law. It should have been like this, the reactivity. Francium, cesium, rubidium, potassium, sodium, lithium. Should have been like that. And then you go to the radon law, radium, barium, strontium, calcium, magnesium, beryllium. If you want a complete one. Right.
Yeah.
So group 1, group 2, group 3 is a better summary than how do I say? It's a more complete summary in case they are tempted to give you other metal, you know what to do. Okay.
Yeah.
So just now was the reaction between metal with cold water. It will be very surprising to you because metal in your experience don't react with cold water. Correct or not?
Yeah.
You don't say I dip iron in water and then it suddenly reacts. You are right. There is nothing wrong with your experience. It's also experimental. Right? So why the heck is he saying that metal with cold water will give you a reaction? What is he saying? He's saying basically group 1 metal and group 2 metal. That is what you call the nasty reactive metals. So the table reaction with cold water stops at group 2. When you go group 3 and below, you see no reaction. That is according to your experience. It is definitely according to your experience. Can you experiment those group 1 metal and group 2 metal?
Yeah.
Probably not. Probably. I hope that they will do it in front of you. So at least
there's videos for us. You can see this.
I mean, yes. It is very how do I say this? We don't go and buy sodium just to put in water. We don't do that. We don't do that.
Yeah, of course.
So we have this. We could, if you want to, we could buy the even worse one, cesium. My goodness, you will explode. So don't do that. Not in your house and not anywhere else.
Isn't uranium the one that explodes?
Uranium don't explode at all. What are you talking about? Uranium don't explode. Doesn't mean that if you press uranium, then it will explode. It does not mean that. I guess that's why we learn physics. That will be in physics. Yeah. So the thing that explodes if you breathe to it is the group 1 metal. But only the I think only the worst offender. Right, whatever. The point of this chapter is that there's an order in how reactive things go, and those things don't change. Proven experimentally, but it's just not part of your experience usually. So you end up memorizing it. Right? Now, I'm going to ask you to compare the other table. Stop jumping around. Stop jumping around. So just now there's a table with cold water. I think they already give you tables with hot water, for example, or as you know it, steam, right?
Where is it?
There you go. There you go. Reaction with steam. Now, before we go further, do you think the reactivity order will be the same or not when you react things with steam? Make a guess.
I think it will be different.
All right. So what you're saying is this, potassium with, stop jumping around. Potassium with water, that's the most reactive guy, right?
Yeah.
Potassium with steam, that's not the most reactive guy. Some
Maybe it's
other
not wrong. I have no
Sorry?
idea. This is just a guess.
True. True, it is a guess because we never hold potassium metal, never, and much less react it with steam. That's so bad. That's safe only in writing, right? Right. Now here's the good news, though. Here's the good news. Turns out the reactivity series on metal is super predictable and never change one. If potassium is reactive when you react it with water, he will be very reactive when you react it with steam.
So this is reactive.
Well, in terms of your limited reactive series, potassium is the most, and therefore with steam, potassium also the most. And then you go down to the sodium and everything, and the order turns out to be the same experimentally. Reacting something with steam is so dangerous. So I keep saying, other people do lah. Other people do lah. And you check the table. You check the table. Not up there, down.
Are you sure?
What are you doing? Why do you keep jumping around? Metal, go to the slide, and then go down, just go down a little bit. There you go.
Oh.
Look at that. Do you see any just now? Do you see any potassium, sodium, and calcium? Do you see that?
No.
Do you know why? Stop jumping. Do you know why?
No.
All right. You have to answer this, by the way. You see this magnesium? Magnesium does appear in the previous table, right?
Yeah.
Magnesium with steam reacts violently, right? Violently. In the previous table, magnesium with water reacts how?
Violently.
No. You go check the table. Go check the table. Magnesium.
Slowly.
Are you sure this is with cold water? You search, just check first. You should, right? So very slowly, right? Very slowly, In magnesium with steam, it reacts violently. Make a guess first why this is so. Is this supposed to be some sort of memory work without logic?
Wait, the formula is like this.
Yeah, I'm going to repeat this as a hint. Magnesium plus cold water reacts slowly. Magnesium with steam reacts violently. Do we have to memorize this, or is there a logic behind it?
Of course, steam is just pretty much the opposite of cold water.
Which is to say, why is that somehow logical?
Because the molecules are faster.
So you react faster, I suppose.
Yeah.
So if I want to summarize this for you, magnesium can already react with cold water. You give it hot water, steam, very hot water, right? Obviously, it will react even faster.
Yeah.
So you don't have to memorize this, right? So to speak. Right? So never mind zinc and iron for a while. My question remains, how come you don't see the guys on top? How come you don't see calcium? Just in the cold water, you see calcium, you see sodium, you see potassium. How come you don't see it here?
What's calcium?
Yeah, where's calcium? Right? Where's calcium?
Reacts readily. That means it must be reacting very fast. The reaction remains the same. So
very violently.
Yeah.
Then what happens if you put sodium with steam?
The sodium. Oh,
Now, why do you need to check this out? Oh, you don't remember that sodium is group 1.
No, not so fast.
Right. So why isn't there calcium, sodium, and potassium in the reaction with steam?
Because it's the same reaction. It's
What
too
do you mean
dangerous.
by the same? Yeah, it's a very fast reaction compared to the cold water one.
I see.
So it doesn't exist here, doesn't mean it doesn't react. In fact, it will react so tremendously fast, which is very dangerous.
Yeah.
And therefore, the reactivity series stays. The reactivity series is exactly the same. It tells you, it helps you predict how things will go, so to speak. Okay?
Yeah.
In the steam, zinc and iron exist, right? Magnesium, remember I told you to remember magnesium group 2, right? And then group 3, then carbon, then zinc, iron. There you go. You have zinc and iron here, right?
Mm.
How come zinc and iron doesn't exist in cold water table?
Because it's even like it's too slow. It won't react.
You check it out. Check it out.
Oh yeah,
No reaction. Right. Is this supposed to be something that we memorize blindly, or it does make sense?
it does.
Good. So you have already mastered the reactivity series plus with water plus with steam. Not master, but you understand it already. Okay?
Yeah.
The third thing is with dilute acid. Why dilute acid? Why not concentrated acid? Maybe you can venture a guess.
Because how do you know it's dilute? Because
I already know. Yeah, right. Yeah, because even with dilute acid, look at how the reaction of potassium go. It's explosive. What do you think if you include the table of concentrated acid?
I think it will be too explosive.
Yeah, because dilute and concentrated. I think logic, right? The concentrated one is even worse, right? Correct. It's just logic already. Now, if you put concentrated acid in the lab without being guarded, sooner or later, some fool will actually put metal into concentrated acid. Some fool. Do you know what will happen if some fool do that?
It'll be explosive.
The whole problem is that the acid beaker is going to explode and splash. That is the whole problem. To the extreme detriment of the fool, which probably is standing very closely. So it's not explosive in terms of bomb. No, not like that, but things splash around. Oh my goodness, that is bad. That is really, really bad. Still bad in that way. It's a chemistry bad, not bomb bad. Now
Yeah.
look at this table. Potassium, sodium, calcium, magnesium, the speed of the reaction. After magnesium, what? After magnesium? Remember from your the first table that I asked you to memorize. Remember that? Group 1, group 2, group 3, and then zinc, lead, zinc, iron, lead. Right? Okay. So predict the table of the dilute hydrochloric acid without looking at it. After magnesium, will you see something else?
Yeah, group 2.
No, calcium magnesium is the group 2. There is no more group 2 that they usually care about. Then group 3 aluminum, which they for some reason don't care at all. I can explain later why. Will you see something else below aluminum?
Yeah.
Which are?
Carbon.
Yeah, carbon. I put it there not to sabotage you, but it's not metal, so you can skip that for now. After carbon?
Iron.
No, zinc first.
Okay.
Zinc and then iron and then lead. So make a prediction. Will you see them?
I mean, yeah.
Predict first lah.
Oh, sorry. But yeah, we did see it.
By experience, when you put acid into iron, you do expect the iron to slowly dissolve lah. That's experiential lah, correct? That's why you don't do that. You don't play with acid around metal and around your own skin.
Okay.
So this is still experiential and it's not fast lah. It is slow enough to damage stuff lah and cause things to tumble, right? My point is, do you have to memorize the table like too much lah, so to speak?
And memorization is memorization. So yeah, I do have to memorize it.
But there is a certain logic to it. Metals have logic. Okay?
Everything is logic.
If you so wish, you still have to memorize. You do have to memorize the reaction. But once you memorize one, you should be able to get the rest.
I mean, I do have to memorize which ones has no reaction.
Correct. Surprisingly, that is the easiest thing to memorize. Surprisingly, you don't memorize the table. Surprisingly, you memorize when it stops. That's the easiest thing to do. So let me repeat this to you. At cold water, do you remember where it stops?
Yeah.
Where?
Magnesium. Group 1.
No, after magnesium.
Group
Magnesium still react. Okay.
Group 2.
Yeah. Now in the steam, do you remember where it stopped?
I have a guess.
What is it?
Copper.
No. After iron. That means iron react after that. No.
Wait, what?
Check it out. Check it out.
Oh, it did. Yeah.
So, acid, same thing, no? Acid also after iron. Iron, then stop.
Yeah.
If you just memorize where they stop, everything else becomes very easy. That's the secret.
Yeah.
Right? So we handle the 3 reaction already. So far, so good?
Yeah. Is that the last reaction?
No. The reactivity series gives you a lot of reaction and makes it manageable, right? I don't know why they give you after the 3 table. They should have given you before to explain everything, right?
Maybe they're planning on making us memorize.
But you already memorized.
I think like they're planning to make us memorize all this before this.
Yeah, I don't think that makes sense. I really don't think that makes sense. Okay. So you have memorized the main reactivity series and you're going to apply it to the 3 reactions and further reactions downward. Okay?
Yeah.
Okay, so using the reactivity series, let me see, go down. Never mind, go down. Just go down.
But you have the slide for them.
I know. Why do you keep saying that? We have to look at the same thing. Why do you keep saying that?
No. Okay, no.
Right now, the displacement thing. Go up. Here. We have a discussion back then. Zinc and copper. We have a discussion back then. Zinc.
Yeah.
Zinc metal meets copper ion. We have a discussion back then. Yeah. Zinc metal meets copper ion. I think it's after
similar.
this. After that guy. Go back. Yeah. You notice that I take the reactivity series from the slide. Okay? Right. So I have a question to close. This is your homework. Okay, this is your homework. Okay, stop jumping around. Zinc metal meets copper metal. That's the first thing. Does anything happen?
No.
Zinc metal
So
meets
yes.
copper. Okay, if you say no, then no. If you say yes, then what happened? You have to describe with the reason, right?
Yeah.
Okay. Then the other 3 combination is very simple. So just now zinc metal with copper metal. Now zinc metal with copper ion. Copper metal, copper ion, very different, right?
Yeah.
Then zinc ion, copper metal, and then zinc ion, copper ion. So there are 4 combo. Right? Tell me the 4 combo.
A zinc and copper.
Metal. Say zinc metal, copper metal. Right?
Okay, zinc metal, copper metal.
Second combo.
Iron metal, iron and copper.
No. There's no iron. If there's iron, then we just take 2 random metal and Oh, goodness me. This is where the semantics is very annoying. I'm so sorry. Iron. I don't mean iron. This is so annoying. I'm so sorry. English and chemistry is just very bad. I don't mean iron. I mean ion. I don't mean iron. I'm so sorry with it. I'm so sorry. I apologize for English. Okay. I do not involve the metal iron in any way.
Okay.
Okay. So try the combo again.
So we zinc and copper.
Zinc, metal, copper, metal. Then
zinc and silver.
No. I don't involve any other metal. Listen to me. Zinc metal, copper metal. Then zinc ion, copper metal.
And copper ion, zinc metal, and zinc ion, copper ion.
Yes, that's the combo.
Okay.
The homework is very simple. What will happen? If there's anything happen, if no, then no. If yes, then you tell an explanation.
Okay.
That's the homework. Okay. Now let me see your slide until the end, so I can decide whether you should read more or not.
Oh wait, let me type this up.
Yes, please. So for tomorrow, you have two homeworks. The chemistry homework just now, very simple one, and then the math one, more complicated. Yeah. Good. Go back to the slide, please. I guess you can move the slide backward if you want to, if that makes more sense too. I guess you can do that also. Right, that's fine. Now go back to the slide, please. Now go down, down, yeah, down. Go down, further down. Yeah, you should have read this, but it will be difficult to understand.
Okay.
This is extracting metal, right? Yeah, everything from now is explained by the reactivity series. Everything from now. So they keep giving you new reactions. If you keep memorizing them, you are done for. First of all, it's a lot of unnecessary suffering. Secondly, we cannot even memorize properly. Too much. They throw at you reactions after reaction, including here extracting metal. Reaction after reaction, every reaction. Everything is explained by the reactivity series. If you somehow don't see the connection, you work on that logic. And then you suddenly become a happy person in chemistry. A person who does not have to memorize so many things. Just one thing, the reactivity series. Explaining a lot of things. That is the goal of this humongous chapter.
So the usage of the reactivity series.
In the application, right?
Yeah.
Again, the moment they throw at you something new and you don't see the connection, that is your number one question. What does this have to do with reactivity series? What does extracting metal have to do with reactivity series? What do they have to do? If you can answer that, good luck. You're on the right track. Okay, so I'm not asking you to read more right now. No point reading more. We should understand more. After you understand this chapter, you can suddenly do a few of the year 4 exam, which is hopefully what we can go through tomorrow. Then you see the connection. Okay.
Yeah.
Time is up. Right. Any other question?
No.
Do you think you can keep up with the speed so far?
Yeah, it seems okay.
All right. Then I'll see you tomorrow.
Okay. See you. Bye. Have a good night.
You too.